This is problem number 4 from the review sheet for exam number 3, our exam covering linear equations in one variable. Remember our approach. We're going to first look at our equation to see if there are any fractions. If there are, we will remove those fractions by multiplying times both sides of the equation with the least common denominator. Fortunately, this equation has no fractions, so we go to step 2 in our steps to solving this kind of equation. Step 2, the key word is parentheses. That tells us that if we have parentheses in the equation, we will remove the parentheses by using our distributive property. So let's perform that step next. I'll distribute the multiplication of 2 times the 2 terms that are in this set of parentheses. 2x minus 6 is what we create when we perform that distributive operation. Now let's distribute the multiplication here, remembering that this minus sign is going to change the signs, and then we'll have to multiply times 3. So it'll be minus 3x minus 15. The minus sign in front of a set of parentheses changes the signs of the terms inside when the parentheses are removed. So minus the plus becomes minus. 3 times x is 3x, 3 times 5 is 15. Let's remove the set of parentheses there in the right-hand expression. And remember, we don't multiply the 3 times the 7 because the 7 is not inside the parentheses. We only multiply the outside factor times the terms that are inside the parentheses. So that was step 2. Step 1 is fractions. Step 2 up the line is parentheses. Step 3 is expressions. We look at the expressions that we have and see if there are like terms we can combine inside those expressions. And we have some like terms in this expression we can combine. 2x minus 3x, that's negative 1x. Minus 6 minus 15 more is equivalent to minus 21. If you owe $6 and you owe 15 more dollars, that's equivalent to owing $21. There's no x term on this side of the equation that we can combine, but we owe 6, we owe 7 more, that's equivalent to owing 13. That's minus 13. Fractions, parentheses, expressions, only one variable term. I want only one variable term in my equation. I have 2 terms in this equation that have the variable. I only want one term to have the variable. So I want to make one of those terms disappear into 0. I'm going to make the minus 1x term disappear into 0 by adding 1x to this side of the equation. But remember, what we add or subtract from one side of an equation, we must add or subtract from the other side, because an equation is a balance, and we have to maintain that balance by putting the same thing on both sides of the balance or taking the same thing off. Those disappear into 0, leaving us negative 21x is the only term in the left-hand expression. 3x plus 1x is 4x. And now I only have one term with the variable in my equation. So fractions, parentheses, expressions, only one variable term. And now the next key word was isolate. We're going to isolate the variable term. The variable term is not isolated. It has this constant term with it on the same side of the equation. I need to get rid of this constant term so as to isolate the variable term. I'll do that. I'll isolate it by removing that minus 13 term by adding 13. And if I added something to one side of the balance, one side of the equation, I have to add the same thing to the other side of the balance, to the other side of the equation. You owe $21, but you have 13. That's the same as owing 8. And minus 13 plus 13 disappears into 0. And the last step, we want that coefficient to be 1. And we get that coefficient to be 1 by dividing both sides by the coefficient that's present, because any non-zero number divided by itself is 1. So that gives us x, and since we divided one side of the equation by 4, we have to divide the other side by 4. Negative 8 divided by 4 is negative 2. So the solution to this equation, the value that if we plugged it in for x, it would make the left side become the same value as the right side, that solution is negative 2.